Welcome to the SafetyWorks Training Institute's presentation of heat illness prevention programs. We're going to be talking today about identifying heat-related illnesses, how to treat those. We'll also discuss screening and assessment of heat hazards. We'll also talk about controlling those heat hazards and resources you can use to keep your employees safe during the heat. Now, every year, millions of employees are affected and exposed to heat in the workplace. Dozens will die and thousands will get a heat-related illness. Now, although heat is not regulated by OSHA, it is a recognized and known hazard, and therefore employers need to ensure that their employees are safe in the heat, whether indoors around radiant surfaces or outdoors under the sun. Now, it's important that employees are acclimatized, particularly when working outside in the heat, or brand new employees working in indoor temperatures that are extremely high. So we'll be talking about acclimatization later on in this program, and that is getting your workers' bodies ready and tolerant of the heat prior to putting in a full day and a full workload. Now, hazardous workplaces consists of every industry, whether you're in construction working on roofs and roadways, industry working around hot internal processes and or equipment, bakeries, ovens, boiler rooms, etc. Agriculture, you're working out in the hot sun as well. Maritime, you may be outside. So all of these places, depending on the season or if you're indoors, may involve heat hazards. We'll talk about the 5 heat-related illnesses. From most severe to least severe would be heat stroke, heat exhaustion, heat syncope, also known as fainting or passing out, heat cramps, and heat rash. Regardless of the illness, regardless of the severity, the OSHA campaign of water, rest, shade applies for both prevention and treatment. So if you can get your employees to remember water, rest, shade, they'll always know what to do in every situation. As we discuss water later on in the program, it's important to make sure that employees that are exposed to high heat hazards have clean, potable, and even better electrolyte replenishing fluids available to them. They should also have rest, a rest period, time to work, time to rest, to give the body time to reacclimate and cool down the body's core temperature. And shade. If you're inside, you can do things with ventilation and fans, etc. But if you're outside, you may have to have natural resources such as trees or even open canopies so the wind can blow around, but to get that direct sunlight off of your employees. Some pieces of equipment outside may also have a canopy that you can put over your employees to also take away some of that direct sunlight. But once again, whether you're treating or whether you're trying to prevent, water, rest, shade. So I'm going to take you to a resource right now that you can find on OSHA's website for heat stress. So hold on just a moment. This is a document that comes from the CDC or cdc.gov. I'm sure if you Google first aid for heat illness, you'll find it. If you get a copy of this presentation, there is a link to it as well. As you can see, it shows the 5 different illnesses we discussed: heat rash, heat cramps, heat syncope, heat exhaustion, and heat stroke. All 5 of them, treatment is water, rest, shade. But as we get into the most severe, the exhaustion and the stroke, you're going to add cooling therapy to that. In both of those situations, the body's core temperature has increased, and you've got to get that temperature down. So we encourage employers cold water compresses on the neck, armpits, groin, wiping down the face, the arms with cool water, getting them out of hot restrictive clothing or PPE that they might have as you get them in the shade. But exhaustion and heat stroke, which usually in addition to other symptoms like fatigue, potentially fainting, etc., when you get into exhaustion and heat stroke, you'll have some level of altered mental state. They may not know where they're at or what they were doing or the time of day. At that point in time, you definitely need to get people medical treatment. Exhaustion can go to heat stroke within 15 minutes. The core body temperature can continue to rise for 15 minutes. And the next thing you know, it is heat stroke. And heat stroke is extremely dangerous. As you can see off to the side in this, it is often fatal. So it's super important that when you train your employees, most are not going to remember all the signs and symptoms of rashes, cramps, fainting. And then when you get into exhaustion, you're looking at headache, nausea, dizziness, weakness, irritability, extreme thirst, heavy sweating. When you lose the ability to sweat, when you see that an employee is dry, they're probably at the point of heat stroke at that point. So most employees are not going to remember all the different signs and symptoms. So as an employer, it's a great idea to post these in areas of high heat and make sure you do training, as we're going to discuss later on in the presentation. But this is a good document to train employees with. It's also a good document to post within your workforce. Now, there are many risk factors that people can have, and there's 3 different types of risk factors. There's environmental, behavioral, as well as personal risk factors. We'll talk about the environmental risk factors, which include the sunlight, direct sunlight, the temperature, the humidity, how much wind there is. Those environmental factors will all influence the heat stress put on an employee's body. Things that behavioral will be: how much have they been drinking? How big is their workload? How hard have they been working, etc. And then when we look at personal factors, things like the medications they're on, existing health issues. It could be things such as, have they had an intolerance to sun and a previous heat-related illness? And pregnancy also could be a risk factor when you're working in the heat. So as employers, it's our job to anticipate, recognize, evaluate, and control the hazards. Here in Maine, you can anticipate hazards that there will be days during the summer that are going to be over 80 degrees. And when you're over 80 degrees, this is when we need to start anticipating that we're going to have heat-related health hazards. How we recognize those hazards is through the environmental factors, the personal factors, as well as the workload and PPE employees will be wearing. So we can easily anticipate and recognize when those high temperature days come, both inside and outside, they will affect employees. If you're inside in a high hot environment all the time, then it's important that as the temperatures rise, how is that affecting people inside your workforce as well? Now, there's 2 ways that we can prepare as employers to know, is there a heat hazard coming? First of all, there's screening, and screening is limited in that, one, it's going to give you an adjusted temperature. Many times you'll look at a weather forecast and they'll say, well, it's 96 degrees, but it feels like 115. So the 96 degrees plus the humidity gives us the feels like, and that's a heat index. And it's a nice indicator of, is there potentially a problem? But what it doesn't take into consideration is things like the wind speed. Are you in direct sun, or is it mostly cloudy, or is it a cloudy day? It does not consider their workload, and it does not consider the clothing that they're in. So this is why this is only a screening tool, but it's a good screening tool that you can use. As you can see by the screen that I have here, this is the National Weather Service's heat index. And all you have to do, go to the National Weather Service or go to any of your weather provider apps and get the current heat and humidity, temperature and humidity, and you can essentially pinpoint on this map what it feels like, what that adjusted temperature is. And as you can see by the color coding, it's going to tell you how dangerous it is for your employees to be working in the heat at that point in time. Now, this is a nice, easy tool. It's great for safety people that may have many locations because you can get the weather by zip code. You can also see when it's going to be hottest during the day, so you can put that information in. Because maybe in the morning or late afternoon, it's not going to be bad, but midday, you're going to want to know how hot is it going to be at that point in time. So it's a nice screening tool that you can use. Like I said, that's the National Weather Service. If you Google National Weather Service heat index, it comes up with this, but it does tell you that the second problem, problem's probably not the right word, the second limitation is that this was devised with light wind, shady conditions. So if it is a bright sunny day and you've got this hot wind blowing around, it can actually raise the temperature 15 degrees above what the adjusted temperature is on this heat index. So you need to be super careful about using this kind of as the be all end all, because as we said, it's not taking everything into consideration. Now, there's another way that you can screen. Same limitations on this app exist. It's not going to take into consideration the direct sun or wind conditions. It doesn't consider what they're wearing or what they're doing. But the NIOSH OSHA Heat Index app is another screening tool that you can use. As you can see here on the screen, you can put in, you can have it do your location, or you can put in a zip code. It's going to tell you the current temperature and humidity, and then it's going to give you a risk factor. The great thing about this tool also is, as you can see below, not only does it give you the feels like heat index temperature, it will tell you precautions for whatever has come up. It will, on the bottom, you see the clock. The clock is an hourly feels like, so that you can see where the hottest part of your day is going to be for that location. They also give you the different illnesses, and they also give you treatment for those illnesses. So if you have supervisors that have phones, I would encourage you to have these apps on their phones. They're a quick reference for what's going on right now, as well as what's coming up and what might I do if I need treatment, because we're not always going to have those posters around. So this is a nice app to use, but once again, like the Weather Service Heat Index, it could be up to 15 degrees off if your employees are working in the direct sun with a hot, windy condition. All those things may raise that temperature on you. Now, to get a little technical, OSHA Technical Manual, which is what OSHA employees use for compliance, they actually have a chapter on heat stress, and there is a heat stress formula, which means that if OSHA has a chapter on it, you know that they're going to be looking for this as a hazard in the workforce. Now, there may not be something regulatory that says, well, you can't expose employees to X, Y, Z, but it is a recognized hazard. And if you have employees that have had heat-related illness and or injury related from that, then they can cite under the general duty clause. So if you see the heat stress formula, first of all, it is the heat generated by the body, and that is our metabolic heat. And that heat generated by the body is going to be influenced by maybe our physical condition as well as the work that we're performing. As we work harder, our bodies are going to heat up. We're going to add to that the heat gain from the environment. So if it's a hot, sunny day, humid, that too is going to increase our core body temperature. But then you may be able to take away heat lost from the body to the environment, meaning our body will cool down some. That's why we sweat. Depending on the clothes, it may add to the heat of the body. It may remain neutral, or it may actually decrease, help us cool down. You may have PPE like a cooling vest that will help bring the body temperature down. All of those things are going to affect our heat stress that's placed on the body. So I'm going to get a little technical here, and we're going to talk about the ACGIH, the American Conference of Governmental Industrial Hygienists. They actually have a hazard assessment that you can perform. All right. First of all, you'll measure, and you'll need a wet bulb globe thermometer. We're going to talk about that in the next step. You can actually have the physical device, or I can show you how to get that temperature without having the piece of equipment. Secondly, we're going to adjust for clothing. We're going to also adjust for the workload, and then we're going to evaluate that against the ACGIH action level and threshold limit value. So let's go to step one. So step one is you can purchase a wet bulb globe thermometer. They probably run from $100 to $500. You can probably get some that are even more technical than that. They're great for if you're there and you're testing right then and there. They give you that temperature on the spot. But the limitations are, if I'm managing many work sites, I can't run to every work site at the same point in time and determine what their hazard is. So I could either buy this piece of equipment for all my supervisors, say if they have hot environments all the time or a lot that there's a significant hazard, or I can use the second option, which is measuring and creating that temperature using a calculator. You can Google, there's many calculators for wet bulb globe temperature. OSHA has 2 on their website. I will say, usually there's a disclaimer about, we're always working on these things, make sure you're using the current temperatures and times, etc. So it's super important to read up on the calculator that you're using. But OSHA does have 2 that's available on the website. If you download this PowerPoint, there is a link to a calculator through OSHA that I've used, but I will tell you, you need to be careful of using the time feature on it because it's set for Greenwich Mean Time. So you need to make sure you're putting in the time that you want to calculate. If you're trying to do midday, you need to make sure you're putting in the time for midday Greenwich Mean Time for your location. There is a set time function on there. If you click it, it's going to set it to where it needs to be and it will be fine. But just be careful of those little nuances in any calculator that you're using. Okay, so in this example, what I've provided is a look at a national weather forecast for Tucson, Arizona. I couldn't get a hot day and a hot temperature for here in Maine, so I went to Tucson. And as you can see, it was 115 degrees. It was partly cloudy. There's a wind temperature there. There's a humidity there, and there's a barometric pressure. As you can see, they've got a heat index temperature, so you don't even need, you don't even need your app. You know that it feels like a certain temperature. And you can go to the index and determine, well, is that, extreme caution, et cetera, and it will tell you that. But as we talked about heat index, there's some limitations there, and we're trying to take the next step in this assessment. So what you're going to need to do is from your app, you need to get the temperature in Fahrenheit for most of these calculators. You'll need the humidity, the wind speed, the barometric pressure, and you need to know what that cloud cover is. As you can see from the chart below it, the cloud cover of mostly cloudy will then have a number associated with it. You can't put mostly cloudy into a calculator, it doesn't understand it. So as you can see by the numbers off to the side, it's giving you that irradiance factor, a number that you're going to put in the calculator. And I'm going to show you the calculator that I use. So hold on just a moment. So hopefully you can see this screen. This is the wet bulb globe thermometer that I pulled off of OSHA's website. And I put in some numbers. I put in an air temperature of 90 degrees Fahrenheit. I put the solar irradiance as sunny, which is 1,000. Wind speed of 10, a relative humidity of 50. I could set the current time. As you can see, it just flipped. That's calculating what it is at Greenwich Mean Time. But for me, it's 10:34 on June 18th. And the barometric pressure is put in there. There's a bunch of different temperatures, but what we're looking for is the wet bulb globe temperature. And this is saying that it currently is at 84.6 degrees Fahrenheit. Now, this calculator gives you an Army work rest regimen. So if you were in the Army, you were doing an easy workload, they would say, you know, you can continue doing what you're doing with that easy workload, but make sure you drink 1 quart every 2 hours of water. And then they have a moderate and they have a hard. So if they're doing a hard workload, they should work 30 minutes and rest 30 minutes and 1 quart every hour of water. And as you see below that is OSHA's work rest regimen. If you're doing a light workload, they're saying it's okay. That doesn't mean you don't provide water. You certainly will want to, but they're saying you shouldn't have, all things considered, a heat-related illness. If you're doing a moderate workload, and we'll talk about those definitions here in a second, you do 50-50 work and rest. So 30 minutes of work, 30 minutes of rest, and then they have a heavy workload as well. So now that you have your wet bulb globe temperature, you're going to need to convert that from Fahrenheit to Celsius, which once again, you know, there's an easy way to do those calculations on the web, on the internet. You just put in Fahrenheit to Celsius and it will give you that. When you're looking at 90 to 115, you're always somewhere up around, say, the 80 degrees Celsius at that point in time, 30 to 35 degrees Celsius. So whatever you come up with for your wet bulb globe temperature, convert that over to Celsius, and then you'd move on to step 2. Now, step 2 is adjusting for the clothing. And what you'll do for this step is in the table below, you'll see that there's a clothing adjustment factor. So if your employees, whatever clothing they're wearing, whatever PPE that might be in this chart, you will add that clothing adjustment factor to the wet bulb globe temperature in Celsius. So if it was 35 and there's a clothing adjustment factor of 1, then it's now 36 degrees Celsius. That is your effective wet bulb globe temperature. Okay, so hold that number because you're going to need to remember that number. Say it's 36 degrees Celsius. And the next thing you're going to do is you're going to determine their workload. How hard are they working? And as you can see, there's a number associated with each one of these as well, depending on how hard of a workload they're working. When you have these two numbers, 36 degrees Celsius, and this other number, say it's moderate or heavy, which is 410 or 415, you will then compare it to the ACGIH chart here. On the left is the Celsius, on the bottom is that workload number, and you will pinpoint where exactly those two measurements meet. Now, anything that's above the dotted line, above the action limit, but below the threshold limit value, which is the solid line, anything that's in that space is considered the action level for non-acclimatized workers, meaning if your workforce has not been acclimatized to that temperature and that time and that workload, then you need to make sure that you put controls in place and you monitor your people to ensure that they don't get a heat-related illness. So that action level is a recommendation by ACGIH for non-acclimatized workers. If your number falls in the threshold limit value or above, regardless of if they're acclimatized or not, that is a high heat hazard and you need to protect your employees. And we'll talk about those controls next. So hierarchy of controls, OSHA always wants you to do the hierarchy of controls. We cannot eliminate or substitute the sun, the heat, unfortunately. For internal systems, you may be able to eliminate heat sources or substitute something that runs at a lower temperature than a higher temperature. It depends on your process, but something you should definitely consider. But most organizations are going to go right to engineering controls. Now, engineering controls outside, as I mentioned before, would be things like providing shade and canopy. And if you have the right equipment, you may be able to have air-conditioned cabs on some of your equipment that you might be using outdoors. Indoors, it's, you can add cooling systems, you can insulate hot surfaces, stop leaking hot steam valves or pipes. You may erect barriers, you may put people in isolation booths that are cooled outside to compared to the outside hot temperatures by the equipment. You can also provide air conditioning, ventilation, and portable fans. I caution you that if your ventilation system is set up to control air contaminants, that if you change air intake to cool your people, you need to ensure that you have not changed what you need to protect them from air hazards. Drinking water accessibility. This is probably the most important thing, is making sure water is available. What did we say? Water, rest, shade. So water, if you can, encourage them to drink at least a quart every hour. It's sometimes hard to get people to drink water. I know in other places we've had things like popsicles. We'll do Gatorade because Gatorade, don't want to use a brand name. I'm sure there's plenty of others out there, but some kind of electrolyte replenishing fluid. Now, if it's engineered, you can engineer that system in by piping in potable water. But if you cannot, you'll want to provide good, clean water and the cups, etc., that complies with sanitation standard around cups and water and drinking water. Another administrative control is having an acclimatizing program. If you work consistently in a high heat environment, this is extremely important for brand new employees. If you work in a location where temperatures are above 80 consistently, then you definitely want to do this as well. Acclimatizing is bringing employees into high heat environments, say 20% the first day and increasing 20% every single day. An acclimatizing program may take 7 to 14 days. You're trying to get them acclimatized, their body to tolerate the heat at the workload that they're working. So you can slowly and steadily increase that for your workforce. And if anyone has been out of work for an extended absence for like a week or more, you may need to re-acclimatize them over a period of, say, 2 to 3 days to get them back into that environment. You can schedule work earlier or later in the day. 10 to 2 is always probably going to be the hottest time of the day. Consistently, that's when the sun is highest and hottest. But if it's cloudy at noon, but at 3 that sun comes right out and it's still hot and humid, that may be your hottest time of the day. That's why it's always good to look at your hourly forecast to know what's going on and not just assume 10 to 2 is going to be the hottest time. Make sure you incorporate those work rest schedules. Even if they're acclimatized, those high heat temperatures, you still want to give your employees adequate recovery time for the workload that they're doing. They say there's some standards, suggestions, 10 minutes every 2 hours, but that's a pretty light workload, standard for a really light workload, not super extremely high heat. So as you can see by that calculator, there's other suggestions that you can use and follow, and we encourage you to do that. Limit strenuous work, and if you don't have to go outside on a day when it's super hot and humid, don't do it. Use relief workers whenever needed, and particularly if you have employees that are working alone, provide them some kind of communication system to be able to report signs or symptoms or get help and treatment if for some reason they're experiencing a heat-related illness. You can also have a medical monitoring program. Usually an organization that has a high heat environment all the time may have this. They may have pre-placement and periodic medical evaluations for employees. Are they physically able to work in that high heat environment consistently? And then there may be a plan for monitoring workers' body temperature, pulse, hydration, blood pressure, et cetera, to make sure their core body temperature isn't creeping up into a zone that is hazardous. All employers should have a training program. Employees should be trained prior to working in a high heat environment. They should also be trained annually. And what they should be trained on is how to prevent heat-related illnesses through proper hydration, risk factors, your acclimatization program. What does that look like? What's going to be expected of them? And the PPE and care and use of the PPE for the heat hazards. They need to know how to recognize and report heat-related illnesses and provide treatment for heat-related illnesses. Now, they may not be your emergency responder, but everyone can learn water, rest, shade. Supervisors should have all of that training, but they should also know how to screen and assess for heat stress, how to control those heat hazards, have the resources, authority to be able to control those heat stress hazards, and the knowledge of heat-related treatment. There's personal protective equipment you can use during these high temperature days. As you can see, here's a list. Every employer is required to do a certificate of hazard assessment. This is also known as a PPE assessment. So your organization should determine on hot, high hazard heat days what PPE will be required. Train your employees how to use that PPE, how to care for it, etc. And lastly, OSHA record keeping. Heat stress is an illness and may require medical treatment beyond first aid. Medical treatment beyond first aid may be IV fluids, and they may be admitted to a hospital. First aid is cooling therapy fluids that you've given them. So this may be a recordable. You'd have to follow the rules for recordability. And if it does result in an admission or a fatality, it is reportable to OSHA as well. So the next screen is our resources, probably hard to see, but hopefully you'll download this presentation, print out some resources for your employees, for yourselves, dig into this further. But this has been the SafetyWorks Training Institute's presentation of heat-related illnesses, and we hope that you don't have to worry about heat stress, but that now you're prepared for heat stress. Thank you.